Okay, welcome back to part one of our class on fundamental math for solar applications, where we're going to talk about basic math operations. The first thing we want to look at is converting temperatures and subtracting temperatures. And really we're looking at the difference from standard test conditions. You can see the little asterisks in our equation here. 25 degrees C is our standard test condition temperature. We use this a lot. And oftentimes we're trying to find the difference between our actual temperature, be it in the case of the equation here, our low temperature or a high temperature, and the difference between that temperature and standard test conditions. So here we want to see what is the difference between a negative 18 degree low and standard test conditions. So we're subtracting standard test conditions from the negative 18 degree. And in this case, if we have our number line, if we're taking that negative 18 degrees C, and if we're subtracting 25 degrees C from it, we're going to go more to the negative. So we can see that we're moving to the left on our number line. We started at negative 18. If we take 25 away from negative 18, we're going to end up at negative 43. So when we're subtracting from a negative number, that negative number is going to become more negative. It's going to become a larger number. Here's another example, same formula. We have a 3 degree C temperature and we're subtracting the 25 degree C standard test condition. If we look at our number line again, in this case we're on the positive 3 degrees Celsius. So we're going to take 25 away from that, so we're going to end up at negative 22 degrees Celsius. So when we're subtracting from those numbers, we're going to go to the negative side of 0. So in this case, that would be below freezing point when we're talking in the Celsius scale. So it's just something to keep in mind when we're working with these type of temperatures. When we're subtracting from these small numbers, we'll go to the negative side, or when we're subtracting from a negative number, it's going to make the negative number larger. And this is important when we get into calculating voltages and taking the difference between standard test conditions and a negative temperature number. We need to know what those differences are. All right, let's talk about multiplication. When we are multiplying things, the order that we put the numbers in the formula does not matter. We're going to get the same results whether number A is first and number B is second, or whether B is first and A is second. Doesn't matter. We're going to get the same thing. So here's an example. We're going to calculate the DC array size. We are using 455 watt modules. There are 24 of them. If we multiply 455 by 24, we get 10,920 watts. Now if we reverse that and multiply 24 by 455 watts, we get the same thing, 10,920 watts. So pretty simple, straightforward, easy multiplication. Doesn't matter which order you do it in, you'll get the same result either way. Now, one thing to know when we are talking about watts, kilowatts, megawatts, gigawatts, it follow the same convention as the metric scale. So 1,000 watts equal 1 kilowatt, 1,000 kilowatts equals a megawatt, 1,000 megawatts equals a gigawatt. So that's how we do those conversions there. In this example, what we're essentially doing, if we want to convert the 10,920 watts to kilowatts, what we're essentially doing is taking that 10,920 watts, multiplying by 1 kilowatt, and dividing by 1,000 watts, and we'll get 10.92 kilowatts. And what we're doing is canceling out the watt symbol. That's why we have that 1 kilowatt in there. That's to get the kilowatts over to the other side. So basically all we need to do is move the decimal place to the left 3 points. That 10,920 becomes 10.92 kilowatts. Now when we talk about division, the order in which you do the equation really matters. It makes a difference. We're going to see an example here in a second. Depending on which number you put first, you're going to get different results. So I try to think of it as the numbers go in the order of what we're trying to find. So if we're looking for cost per watt, the cost is going to go first and the watt is going to go second. If we do it the other way around, we're going to get a different result. So let's take a look at an example of that. We're going to calculate cost per watt of a system. We have an 8,400 watt DC PV array. It's going to cost $26,040. That's our total cost. So if we want to find cost per watt, we need to put the cost first in the formula and the watt second in the formula. So we're going to take $26,040 divide by 8,400 watts, and that is going to give us $3.10 per watt. That's our cost per watt. Now, if we reversed this formula and did 8,400 watts divided by $26,040, what we get is not dollars per watts, we're getting watts per dollar. Now, as the asterisk says here, this is an accurate value. This is the watts per dollar, but that's not what we were looking for. We were looking for dollars per watts, and nobody uses watts per dollar in the solar industry. It's just not a metric that we use. What'll oftentimes we see students do is they'll do this watts per dollar calculation and get 0.32 and figure, oh, I must have messed up the decimal somewhere and that's $3.20 per watt, but that's not what it is. You're getting watts per dollar, not dollars per watt. So when you're thinking about division, it's really important to make sure you've got the numbers in the right order in the formula to get the result that you're looking for. If you get them backwards, you're going to get something else that's not an accurate number. Okay, multiplication with negative numbers. This also works for division as well. If we are multiplying a positive number by a positive number, we're going to get a positive result. So 4 times 5 equals 20. Pretty straightforward. If we are multiplying a positive by a negative, we're going to get a negative number. So if we multiply 4 by negative 5, we're going to get negative 20. Also, if we multiply a negative by a positive, we're going to get a negative. So negative times positive equals negative. Negative 4 times 5 equals negative 20. If we multiply two negative numbers together, we're going to get a positive number. So negative 4 times negative 5 equals 20. So the thing to remember with this is if there's one negative in our equation, the answer will be negative. The two negatives cancel each other out and our answer will be positive. So one negative, negative answer, two negatives, positive answer. Here's an example. In this case, we have negative 53 degrees Celsius times negative 0.31% per degree C. So those two negatives together cancel each other out. We're going to get a positive 16.4%. And we'll see this more as we do our voltage calculations for the actual voltage of a module under different temperature conditions. In this case, we're under cold temperature, so we're going to see a 16.4% increase in our voltage for that module. Here's another example. Positive 46 degrees Celsius times a negative 0.41% per degree C. We're going to get a negative 18.86% because we only have one negative, so we're going to have a negative result. And you can see in both of these we have the Celsius canceled out because when you're multiplying two things together that have the same label, the two labels will cancel out. So in this case, the two Celsiuses canceled each other out and we're left with a percentage. So that's a percentage change in this case above the standard test condition voltage rating of the module. The key here, again, two negatives are going to equal positive, one negative is going to equal a negative answer. And this is really important when we get into the voltage calculations, because if it's a positive, we're increasing the voltage. If it's a negative percent, we're going to be decreasing the voltage. And if we don't get that positive or negative number right, we're going to be going in the wrong direction. Now let's look at orders of operation. Now there's an acronym sheet here to kind of remember these orders of operation. It's called PEMDAS, and that stands for parentheses, exponents, multiplication and division, and addition and subtraction. So what does that mean? When we are doing a larger formula, we're going to start by doing the calculations that are in parentheses first. And we're going to look at an example in this in a second. But we always start with parentheses and the innermost parentheses first. Then we're going to do our exponents. So I put an example here, x to the 4th power. That would be our next order of operation, would be do those exponent calculations. Now I will say that in the solar industry it is somewhat rare to have exponents in our calculations. We don't really work with exponents a lot. It does happen occasionally, but those are pretty rare circumstances. So usually we're going to start with the parentheses, look for exponents, see if there are any there. There probably aren't going to be any there. And then we're going to move to multiplication and division. Now multiplication and division are on the same level there. So what we're going to do is we're going to start from the left of our equation and move to the right. So if there's division first, then we'll do that division first on the left and then move to multiplication. If there was multiplication to the left, we'll do that first and then move down to the right. Same thing with addition and subtraction. Once we're done with our multiplication and division, we do addition and subtraction starting from the left and moving to the right in the equation. Whatever addition or subtraction is first in the left, we'll do that first and then move to any orders of operation to the going to the right. So here's an example. In this one, this is calculating our actual module voltage. We have 3 sets of parentheses here. We have the inner parentheses right here, this negative 28 degrees C minus 25 degrees C. That's what we're going to do first because that's the innermost parentheses. Then we have a second layer of parentheses. So the result of this subtraction here will get multiplied by this negative 0.31% per degree C. And then we have a bracket which is treated the same as parentheses on the outside. And then we'll add the result of that calculation to 100%. Then the last thing we do is multiplication. By the time we get to that, there'll only be one calculation left to do. So that's pretty straightforward. So let's see how we do that. Again, the first thing we do is the innermost parentheses. So we take that negative 28 degrees C and subtract 25 degrees C from that, and we get negative 53 degrees C. Then we'll do the next most inner parentheses, which is the negative 53 degrees C times negative 0.31% per degree C. And we'll see, since those are two negative numbers, they cancel each other out. The negatives cancel each other out, and the Celsius labels cancel each other out as well, and we're left with 16.4%. We're going to add that to 100% because we're still in parentheses or brackets. In this case, we use the brackets just because there's so many parentheses there. So we're going to do the 100% plus the 16.4% in the bracket. And first we need to convert this, or we're converting this to a decimal in this place, and we're going to talk more about that in a minute. And we get 1.164, and we're going to multiply that by 45, and that's going to give us our final voltage. So this is increased voltage for temperature below standard test conditions. To review, we do parentheses first, and we start from the innermost parentheses and work to the outermost parentheses. Then we look for exponents, then multiplication and division starting from the left and moving to the right, and then addition and subtraction, again starting from the left and moving to the right. And that's how we get the right answer. If we don't follow these orders of operations, then we're going to get an incorrect answer, because the order of operations is really important. If you change the order of operations, your answer is going to change as well. That is the end of part 1. In the next part, we're going to look into decimals and percents and changing one to the other. So take a break, join me for that part when you're ready. Thank you.